Assalamu alaikum viewers, I am Farrukh Nadeem. Today I am bringing you a tutorial that you have been waiting for a long time. What is that tutorial about? For a long time many people have been requesting a tutorial on how to set the parameters of the tool. So in today's session we will, God willing, talk about the tool's parameters and how to set them. Up until now everyone has been working in their own way. Some have set certain values in their practice, others have set different ones. Today we will distill all those values to understand what they actually are, and after this session everyone will be able to manage these values themselves, because I am going to take you directly to the underlying logic behind them. Let's begin. Right now I'm just taking a shield here as an example. It's not something we'll actually be working on today, but I'm using it so I can open the tool database. Here we come to the tool database and let's talk about one specific tool. Suppose I talk about Profile Toolpath. As soon as you come to Profile Toolpath, select any one tool here. Alright, you can also select from here. If you want to access the tool database directly, you can select from here as well. So actually, since we want to talk about what tool parameters are in this context, let's pick any one tool and discuss it in a bit more detail. Here we have selected a 3mm end mill tool. When you select a 3mm end mill tool, here you will see all its details. The type of tool, its units, diameter, number of flutes, and then the most important things are these parameters, which we will discuss, such as what its diameter is, and then how many flutes it has, meaning how many cutting blades it has. Alright, now about pass step and step over, these aren't really complicated things because we set them ourselves according to the tool as needed. The standard says that your pass depth, that is the cut, the depth you set refers to the depth between one cut of the tool and the next, that is called pass depth, and here it is written as 1.2. The standard always says to make it half of the diameter. The step over is always 40% of the diameter. Do not exceed this, as it is not correct. It will damage the tool, it will break the tool. If for example the diameter here is 3 and your number of flutes is 2, then the pass depth here will be 1.5 and the step over will automatically be set here as a percentage. If I talk about spindle speed, we usually set the spindle speed between 16,000 and 18,000. Now everything I'm discussing here is because we are working on soft materials. So what are soft materials? Wood, MDF, hard meaning black colored wood, hard and soft wood, acrylic, plastic. These are the kinds of materials we'll be working with here, because the capacity of our routers is such that they can work on soft materials. So we were talking here about pass step, little about step over, and next the most important thing, feeds and speeds. Should you set it at 16,000 RPM or 18,000 RPM? If your router has a good spindle installed, then definitely you can get more than 18,000 RPM as well. Alright, so that's about its speed. After that we come to feed unit. Understand the feed unit, very few people actually know about this. It's measured in inches per minute, meaning when you have to move the tool during touring or cutting, what speed should you set for it? What unit will you use for that? Do you want to set its unit as millimeters per second, meaning how many millimeters are cut in 1 second? Or do you want to set it as millimeters per minute, that is how many millimeters are cut in 1 minute? Or do you want to set it as how many meters are cut in 1 minute? Or how many inches in 1 second, how many inches in 1 minute? Or how many feet per minute do you want it to run at? So everyone uses what they're comfortable with in practice. A common unit that is used is inches per minute, inches per minute. After that we have the feed rate below. Now here we have to set its feed rate accordingly. For example, now we are telling it to set the feed rate at 35 inches per minute, and this is the plunge rate. Feed rate, this is the plunge. So when you do drilling, at what speed do you drill? Next we have the plunge rate. So what is the plunge rate? Basically it is the speed at which we are setting its entry. So what exactly is a plunge rate? We are setting its pass depth. This pass depth value has its own unit. That is the speed at which the tool enters the material to reach the desired depth is what we call the plunge rate. The plunge rate here is set to 10 inches per minute. Inches per minute, so if I convert this to per second, how many millimeters per second? In 1 second it will go down by 4 millimeters. So basically these are its units. Generally our colleagues' practice is to use inches per minute and then the plunge. Regarding the plunge rate, the common practice in the market of what people here usually do, whether it's for pocketing, profiling or any other tool path, and even for carving, as long as it's not too harsh, is to set the plunge rate at about 50% of the feed rate. And typically when doing carving, the plunge rate is usually set to be equal to the feed rate, just to keep things consistent. So on different machines, different people follow their own practices accordingly. But today what I'm going to tell you is how we set inches and millimeters. What is the formula we use to adjust this? So here I'm going to show you a table that contains something written here. Chip load is 0.001 inches because here we are talking in inches per minute. So it will show it in inches. Whether you set the tool in inches or millimeters, that's up to you. When you select millimeters or inches here, the unit will also start displaying accordingly. This is another factor based on which you will set the feed rate. Now the question arises, what exactly is chip load? We have a table for chip load. Now I'm giving you the chip load values for different materials. Please pay close attention to this. It's a very important point. If you understand this, everything else will become easy for you. Look, first it says hardwood. If you are using any hardwood or a black colored wood like shisham or any other type of hardwood, then for a 1 8-inch tool, the chip load you will get is 0.0032 to 0.005. If you are using a 1 4-inch tool, then it will be 0.009 to 0.011. Okay, let me give you a general idea. These are the values you will use for hardwood. For a 1 8-inch tool, for a 1 4-inch tool, for a 3 8-inch tool, for a half-inch or larger tool, if you move to clear plywood, these will be the values. If you move to MDF, then these will be the values. After that, look here, we have hard plastic. If we talk about hard plastic, these are the values. If we talk about clear plastic, then these are the values. After that, here we have basically, these are the required values. Sometimes we have to reduce them by 1 step. So what happens then? Similarly, aluminum is also here, but if you need it, I will definitely share this sheet with you. You should paste it somewhere or print it out. It will be useful for your work. So here I am talking about the tool diameter 0.125. All these values are written in inches. The sheet I am showing you here, all the values are in millimeters. There's hardwood, clear wood or plywood, MDF. And similarly, look here, BSS software, solid, carbon steel, aluminum all. These materials have their chip load values given here with different tool diameters. So if the tool diameter is 3 mm, these will be the values. If it's 6 mm, these will be the values. If it's 10 mm, these will be the values. Now what do you have to do? Look, this will come with practice. Let's go back to our software. Here we set it to 3 mm, and as I told you, the common practice in the market is in inches per minute. So for 3 mm, or if I convert it to inches, it becomes 0.125. Now according to 0.125, look, it has also changed the step over, and here we will have it accordingly. So these values, see, they are in inches per minute. If you set it to millimeters, and if I set it to 3 mm, it will be the same. So the flyout is at 1.5, the pass check is done, and the step over is at 1.24%, 18.0 RPM, and the chip load now, here in inches for a 1 8-inch tool, if I talk about hardwood, the chip load value should be 0.0032 to 0.005. Alright, what you need to do is increase this value, because what value do we need? We need 0.003 or 0.004 or 0.005. Now you can adjust this a little as well. If you have a DSP controller, you can do it from there. If you have NC Studio, there is also an option there. If you have a Vectric, there is also an option there. You can make the feed a bit faster from there as well. So what do I need as an average? 0.004. Let's take an average value between the two, 0.004. Now here it's coming as 0.001. So how will I increase it? Look, if I set its value here to 100, you see it comes to 0.0028. If you set it to 150, it comes to 0.004. So you need to achieve this value keeping your tool and material in mind. Now how will this value be achieved? Let me show you something interesting here. If I adjust this setting and increase the speed to 16,000 revolutions per minute or RPM, you'll notice that this particular value on the display starts to rise accordingly. This happens because the system is designed to respond to changes in RPM, reflecting those adjustments in real time. Now, just to clarify, when I say 16,000 RPM, I'm referring to the speed at which the motor or device is spinning. You can see that as soon as I set it to 16,000, the value shown here updates to reflect that change. This is a direct result of the increased speed. Now let's try something different. If I go back and set the RPM to a different value, say 125, you'll observe that the value on the display changes again. This demonstrates how sensitive the system is to RPM adjustments, and it helps us understand how the device responds to different operational speeds. So by changing the RPM from 16,000 down to 125, we can clearly see the impact on the displayed value, which is a useful way to monitor and control the system's performance. But this will not affect your chip load. This is the position where the tool is inserted into the material. So in this way, if you change the tool, suppose I set this to 6 millimeters, I set this to 6 millimeters, 6 millimeters, then this value will appear. But we need to know what the value should be at 6. I will come to the table. So now we have 6 die as equal. Now, if I want to work on this on clear plastic, what value do I need? 0.007 to 0.01, meaning if I take the average, I take 0.009. So how will this work? We set it to 18,000 RPM. Now I need to set it to 0.009. So look here, give it here. When I set it to 0.009 at 350 inches per minute, it changed it there. Okay, if you change the number of fluids, look, it will change. If the blades are 3, the value will change. If the blades are 4, the value will change. So look, if there are 4 blades, the value will change. So it depends on your fluids and you have to set it accordingly. Usually the number of fluids we have is 2. So the values will also be these for that. So I think you all have understood this a little now. I am going to revise this whole topic in a few words. Listen carefully. We have to maintain the chip load, and to maintain the chip load we will use this chart. Make sure to download this chart and keep it with you. This chart contains the chip load for all the tools. You have to achieve that chip load. If I am working at 200, then its chip load should be 0.009 to 0.11. So this means you have to adjust the chip load within this range. As I told you, if I want to set it to 0.009, then look, 0.009 is here. If the last value is fluctuating a bit, no problem, you just need to give the exact number of flutes. After that, whether you want to set 18,000 RPM, 20,000 RPM, 15,000 or 14,000, whatever RPM you want to use, you must first set the RPM. After setting the RPM, you have to achieve this value using the feed rate and then set the plunge rate to approximately half of that. After doing this, you need to click OK, apply it, and the tool will be saved with these settings. After that, you can proceed with the machining. I hope that today's session, although it was quite short, has shown you exactly how to set the main values within it. By the way, there are also formulas for this, which I am sharing with you on the screen as well. Look, here are the formulas included. You can also do the calculations using them. God willing, I will try to share a calculator with you soon, where you will just need to enter the material and tool diameter, and with the help of these formulas, it will automatically tell you what feed rate you should set. For that, I need a little time, but God willing, after working on it, I will definitely share it with you all. Now, there is one thing to discuss here. What is chip load? Basically, from this diagram, you can understand that when the cutter is cutting, the width of the cut is called the chip load. As you practice these things, you will gradually get a better idea of them. Friends, I hope that today's session has been very, very beneficial for you. You must have gotten an idea that whenever we have to select any cutter, along with it, its feed, retican, spindle speed, number of flutes, chip load, how to manage all of these, how to create their combination. I need your prayers. Please remember me in your prayers. God willing, in the next lecture, we will meet again with a new topic. Allow me to take my leave. Allah Hafiz. Remember me in your prayers. God willing.